I would like to take this opportunity on behalf of DoSCI 2024 and ComSIA 2024 to welcome all the dignitaries, management, organizers, researchers, academicians, and students to the two-day program of Doctoral Symposium on Computational Intelligence and International Conference on Computing and Communication Systems for Industrial Applications, jointly organized by School of Open Learning, University of Delhi, Institute of Engineering and Technology, a constituent college of Dr. APJ Abdul Kalam, Technical University, Lucknow, India. Shahid Rajguru College of Applied Sciences for Women, University of Delhi, and University of Calabria, Italy publication partner, Springer CEUR, workshop proceedings, Elsevier SSRN. We would like to express our sincere gratitude for your presence in this opening ceremony as the gateway to initiation of our scientific program. Overall, more than 1,500 papers have been submitted, and after a rigorous peer review process, only 213 papers have been registered with an acceptance ratio of only 14%. Doctoral Symposium on Computational Intelligence and International Conference on Computing and Communication Systems for Industrial Application is organized with the objective of bringing together innovative scientists, professors, research scholars, students, and industrial experts in the field of computational intelligence, sciences, computational methods, and techniques to a common forum. The primary goal of the conference is to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. Another goal is to promote the transformation of fundamental research into institutional and industrialized research and to convert applied exploration into real time application. Overall, the conference will provide the researchers and attendees with prospect for national and international collaboration and networking among universities and institutions from India and abroad for promoting research. The School of Open Learning, formerly known as the School of Correspondence Course and Continuing Education, established under the University of Delhi in 1962, a pioneer institution in the field of distance education in India. The school offers learning through the distance education mode, which is a viable alternative for students who need a flexible medium of instruction to attain higher education and vocational skills. Institute of Engineering and Technology, Lucknow, popularly known as the Engineering College in Lucknow, is one of the premier and top-ranked institute among all technical institutions associated to Dr. APJ Abdul Kalam Technical University, Lucknow. IET was established by the government of Uttar Pradesh in 1984 as a society-governed institute. The institute is financed by Government of Uttar Pradesh and is being administered by the Executive Council of AKTU. IET Lucknow was started as the Faculty of Engineering and Technology of University of Lucknow. Shahid Rajguru College of Applied Sciences for Women, a constituent college under University of Delhi and funded by Government of NCT of Delhi, was established in the year 1989. The college aims to change lives, build future, and impart technical expertise through high-quality applied learning. The college puts a strong foot forward to imbibe ethical values with the aim of inculcating self-reliance attitude in young women. Now, I would like to request Dr. Deepak Gupta, convener, DoSCI 2024 and ComSIA 2024, to address the gathering.
Thank you, Navya. Good morning, good afternoon, and good evening to all the participants of DoSCI 2024 and ComSIA 2024 around the globe, connected with us from 24 countries. On behalf of DoSCI and ComSIA, I would like to welcome all to the fifth Doctoral Symposium on Computational Intelligence, held with the International Conference on Computing and Communication System for Industrial Application, being organized jointly by School of Open Learning, University of Delhi, Institute of Engineering and Technology, Constitute Institute of Dr. APJ Abdul Kalam Technical University, Lucknow, Shahid Rajguru College of Applied Sciences for Women, University of Delhi, and University of Calabria, Italy. On behalf of the organizing committee of DoSCI and ComSIA, I extend my heartfelt gratitude to the governing management, faculties, staff, and students of organizing institutes, the keynote speakers, our panelists, delegates, session chairs, paper presenters, and participants of this conference for 24 countries. We have more than 200 paper presentations in the coming 2 days in the hybrid mode. First and foremost, I would like to express my heartfelt gratitude and welcome to Professor Vineet Kansal, Director IET Lucknow, Professor Payal Mago, Director School of Open Learning, University of Delhi, Professor Giancarlo Fortino, University of Calabria, Italy, Professor DS Yadav, and Professor Girish Chandra from IET Lucknow, who, despite of their busy schedule, has found time to grace the inaugural ceremony of DoSCI and ComSIA. I would like to welcome our keynote speakers, Professor Robertas from Kaunas University of Technology, Lithuania, Professor Gwangil Zion from National University, South Korea, Dr. Lalit Garg from University of Malta, and Professor Korhan from University of Zagreb, Croatia. We are grateful to them for accepting the invitation to take part in DoSCI and ComSIA and will share their expertise and knowledge with the participants of the conference. We are grateful to our core organizing committee chair and members for supporting us during the organization and implementation of this symposium/conference. Now, I would like to give some of the insights regarding DoSCI and ComSIA. Let me share my screen. It is a fifth version of DoSCI, and we have received around 1003 papers in DoSCI, and only 187 papers have been accepted and registered with an acceptance ratio of 19%. And these papers will be published in Springer LNNS series, which is Scopus indexed. And the symposium is organized by multiple organizers. This is a history. We have started DoSCI in 2020, and I have listed year-wise how many papers have been submitted and how many of them has been accepted and published, and the number of countries. So in 2023, we have a more number of submissions, around more than 1,000, and more number of papers have been accepted, and the countries are also more as compared to the previous versions of our software symposium. Along with the symposium, we are also organized ComSIA, the first international conference on computing and communication system for industrial application, with the School of Open Learning and Shahid Rajguru College of Applied Sciences for Women. And this time, in this first version, it has received around 450 papers, and out of those, only 68 papers has been accepted in two different publishers. Around 48 papers have been published in CEUR workshop proceeding, which is Scopus indexed, and another 20 papers will be published in Springer SDIC series. This is the country-wise paper registered from each country in DoSCI and ComSIA. This is the in this year we have the publication in Springer LNNS 187 papers will be published. CEUR we are going to publish 48 papers, 15 papers in Springer ADIC, and 108 papers in elsewhere SSRM. We have also associated with some high impact factor journals, and we will give the opportunity to the authors of high quality papers to extend their paper by 70%, and they have a chance to publish their papers in these journals also. So at last, I would like to give my special appreciation to Professor Ajay Jaiswal, sir, Dr. Samir Anand, sir, Dr. Ajay Aditya Khamparia, sir, Dr. Parul ma'am, Dr. Upendra Kumar, sir, for giving their time and energy in making this event a huge success. Thank you so much.
Thank you, sir, for your kind words. Now, I would like to call upon Dr. Parul Yadav, CSE IET Lucknow, convener DoSCI 2024, to address the audience.
Thank you, Navya.
Thank you.
I, Dr. Parul Yadav, on behalf of Organizing Committee of 5th Doctoral Symposium on Computational Intelligence, DoSCI 2024, and IET family, feel honored and privileged to welcome Professor Giancarlo Frottino from University of Calabria, Italy, General Chair and Distinguished Speaker to SCI 2024. Professor Vineet Kansal, Director at IIT Lucknow, and Patron to SCI 2024. Professor Payal Mago, Director, Campus of Open Learning, University of Delhi, Patron to SCI 2024. Professor Girish Chandra, HOD CSE, IIT Lucknow, and General Chair. Keynote speakers, Professor Robertas Demisevičius, Kaunas University of Technology, Lithuania, Dr. Lalit Garg, University of Malta, Professor Gongal Jayan, Chen National University, Korea, Dr. Koran Gengrais, University of Zagreb, Croatia. I would like to warmly welcome Honorary Chair Oscar Carlo, Mexico, Professor S.K. Mishra, SGPI, Lucknow, Abu Ela Hassanian, Egypt, our editorial chair, Professor Girish Chandra, Dr. Manik Chandra, Dr. Pawan Kumar Tiwari, Dr. Upendra Kumar from IIT Lucknow, Dr. Ashish Khanna, Dr. Deepak Gupta, Dr. Aditya Khamparia, Professor Ajay Jaiswal, Dr. Samir Anand, convener to SCI 2024. I would like to heartily welcome session chair, reviewers, directors, teams, attendees, faculty members, staff, research scholars, UG and PG students, attendees, joined through Zoom or watching us live at YouTube channel, all the participants, student coordinators, and whole organizing team. A very warm welcome of all of you at the inaugural ceremony of the DoSCI 2024. Thank you, Navya.
Thank you, ma'am, for enlightening us. Now, I would like to invite Professor Girish Chandra, Head CSED, IET Lucknow, for addressing the audience.
Hello, am I audible?
Yes, sir.
Okay. So, Professor Vineet Kansal, the Director, IIT Lucknow, with the patron of this symposium, Payal Mago, Director, Campus of Open Learning, University of Delhi, the Professor D.S. Yadav, General Chair, and Professor Giancarlo Frottino, University of Calabria, Italy, the Honorary Chair, Professor Kaishlo, Professor S.K. Mishra, Professor Ila Hashenian, Dr. Abhishek Sarup, and technical program chairs, the editorial chairs, the publication chairs, conveners, Dr. Parul, Dr. Upen, Dr. Ashish Khanna, Dr. Deepak Gupta, Dr. Aditya Khamparia, Dr. Jaiswal, Dr. Samir Anand, University of Delhi, the researchers, authors, faculty members, the keynote speakers, session chairs, and attendee of the symposium. A very good morning to all of you. I welcome to this inaugural ceremony of this doctoral symposium on the computational intelligence DoSCI 2024, which is fifth in this series now, and in a short period of time is gaining a quite substantial popularity. It is great pleasure to have you all today to mark this beginning of what promises to be an enlightening and intellectually stimulating event. As head of the department, I am thrilled to witness the convergence of some of the brightest minds in the field of artificial intelligence. The research being conducted by the doctoral candidates in this area holds immense promise in revolutionizing the way we perceive and interact with the technology. From machine learning algorithms to neural networks, from natural language processing to robotics, the scope of possibilities within this domain is truly inspiring. The field of intelligence system is evolving at a very rapid pace, and some of the faculty members at our computer science and engineering department are also working in the area and guiding the research students. Since the inception of artificial intelligence, we have an incredible journey moving from fantastic ideas to real-world technology that are changing our world today. The history of AI goes back in time to a time when computers were huge machines capable of performing only the most basic tasks. The first attempt to create AI were limited to programs capable of solving a limited set of tasks. These were the years when the term artificial intelligence sounded like a part of science fictional novels. It was not until 1950 that its real potential was investigated. A generation of scientists and intellectuals had the idea of AI, but it was not until Alan Turing proposed that people solve problems and make decisions using available information and also a region. The computational ability of computers was the major stumbling block to expansion. Over the time, with the development of computing power and big data, AI began to solve problems that seemed unbelievable before. Actually, we can see it in everyday things, from voice assistant on our smartphones to automated driving systems in cars and data analysis in medical research. Machine learning and deep learning technologies have analyzed this development. Neural network have catalyzed this development. The neural network, capable of analyzing vast amount of information and learning from it, have become the main actors in the world of AI. The implementation of AI has already major impact in various aspects of daily living through social media platforms, iPhones, robots, Google Photos, and face and voice recognitions. In the future, we can expect that artificial intelligence will become increasingly capable of self-learning, allowing systems to learn on the fly without requiring constant reprogramming. Global AI network that will open up new perspectives for solving the world's complex problems. It is safe to say that AI will continue to surprise us with its advances. The next wave of development will be in areas that will impact human engagement. Such as healthcare, agriculture sector, banking, transportation, hybrid cars, autonomous airplanes, printed human organs, and domestic travel to outer space. It would be an exciting journey to see how it turns out in the future and how society will adapt to those changes. I would like to take this opportunity to extend my sincere gratitude to all the participants, speakers, faculty advisors, sponsors, and supporters who have contributed to the success of this symposium. Thanks to your effort that events like this are made possible. At the end, I wish all the participants a fruitful and enriching experience at this doctoral symposium on computational intelligence. I hope that this symposium serves as a platform for our doctoral candidates to showcase their groundbreaking research, exchange ideas with fellow scholars, and forge collaborations that have the potential to shape the future of AI. I'm confident that discussions and debates that will take place will enhance our understanding and pave the way for new breakthroughs. Wishing all the best for successful conclusion of DoSCI 2024. Thank you. Thank you all. Thank you, Navya.
Thank you, sir. Thank you, sir, for your kind words. Now, I request Professor Gianco Fortino, University of Calabria, Italy, distinguished speaker, DoSCI 2024, to address the audience. Due to his commitment with another conference in Canada, he is unable to join us today, but he has sent a small message.
Good morning to everyone. I'm Professor Fortino from University of Calabria, and I'm very glad, to give this short speech to open the conference, the Doctoral Symposium on Computational Intelligence 2024. I'm pretty glad that my university supported this important doctoral symposium on a very important topic like computational intelligence. I have to say that we supported the symposium since its very inception, and today in this new edition 2024, I can appreciate also different special sessions on important emerging topics in computational intelligence, like artificial intelligence and machine learning, or intelligent networking, smart technologies, trustworthy-based explainable artificial intelligence for medical application. So a diversified set of important topics in the domain of computational intelligence. So just to conclude, I'd like to wish to all of you to profit a lot, specifically, young people, PhD students, to profit a lot from this conference, from the works, the papers of this conference, and to participate actively, okay, by asking questions, by brainstorming, by reflecting, and by cooperating with each other. So my very and great wish to all of you, to spend, let's say, great time in this important event. Thank you very much, and I hope to meet you physically in the near future.
Thank you, sir, for the empowering speech. Now, I request Professor Payal Mago, Director Campus of Open Learning, University of Delhi, to address the gathering.
Thank you, Navya. All the dignitaries and participants present here. Professor D.S. Yadav, General Chair, DoSCI. Professor Vineet Kansal, Director, IET Lucknow. Professor Girish Chandra, Head, Computer Science Department, IET Lucknow. Professor Fortino, University of Calabria, Italy. Dr. Deepak Gupta, Dr. Parul Gupta, Dr. All participants and delegates. My important conference, which will be very helpful to participate in the ongoing. And as you know, that computer vision is an innovative technology that has made significant advancements in recent years, allowing computers to understand and analyze visual information in a way that is comparable to human perception. The field of computer vision is seeing rapid growth, leading to numerous advancements and creating opportunities for diverse applications across several industries. With artificial intelligence gaining momentum, the field of computational intelligence and advancing computer technology will gain greater significance, and conferences and symposia like this will help young learners stay updated with these trends. To further take up this vision, this year a fifth doctoral symposium on computational intelligence, DoSCI 24, is being jointly organized by School of Open Learning, University of Delhi, Shahid Rajguru College of Applied Sciences for Women, University of Delhi, and Institute of Engineering and Technology, a constituent institute of Dr. APJ Abdul Kalam Technical University, Lucknow, India, in association with University of Calabria, Italy. Now, the goal of this fifth doctoral symposium on computational intelligence is to provide a shared forum for cutting-edge scientists, academicians, research scholars, students, and industry professionals working in the field of computational intelligence. This year, ComSIA 2024 has received 450 papers, which is really commendable, from 14 countries, and only 65 papers have been accepted for publication in the proceeding of ComSIA 2024. 48 papers will be published in CEUR workshop proceedings, and 17 papers will be published in Springer ADIC. On the other hand, DoSCI 24 has received 103 papers from 20 countries, and only 187 have been accepted for publication in Springer LNMS with an acceptance ratio of only 19%. Sessions to be conducted in recent advances in artificial intelligence and machine learning are like intelligence network, techniques and applications, smart technologies utilizing artificial intelligence, the Internet of Things and blockchain, recent advancements, innovations, future trends in emerging technologies, and their impact on, and so much more sessions will include the latest developments. This will help in driving innovation and technological advancements to enhance decision making processes and efficiency, enable personalized experiences for the user. I welcome all the participants and delegates, and I hope that this conference will serve as a catalyst for innovation and improvement in the labor market, having a huge impact on society by addressing global concern and promoting economic changes. The advancement will provide fresh prospects and reconfigure established sectors, resulting in favorable socio-economic changes. With this, I once again welcome all the participants and delegates, and my best wishes for the successful completion of this conference. Thank you so much.
Thank you, ma'am, for your words of wisdom. Now, I would like to call upon Professor Vineet Kansal, Director, IET Lucknow, to address the audience.
Thank you, Navya, and thank you very much. This is the fifth version of DoSCI, and being the part and the patron of this DoSCI fifth version, I just recall that 5-year journey of this DoSCI. This fifth version of DoSCI is being organized today and tomorrow with the effort of 4 organizing bodies: the 2 colleges of Delhi University, University of Calabria, and Institute of Engineering and Technology, Lucknow. Institute of Engineering and Technology, Lucknow, I would like to, state upon that it is not only the constituent college of Dr. APJ Abdul Kalam Technical University, it is also the autonomous institution also. Not only this, we have 5 UG programs of our college, which are NBA, National Board of Accreditation accredited, and Computer Science and Engineering program is one of them under Tier 1. Having said this, organizing the conference and doctoral symposium like this is not a one-day effort. It's a round-the-year activity, and for that, all the people have worked very, very hard. I would like to thank Dr. Ashish, Dr. Deepak, and the team of IET Lucknow, the head of the department, Dr. Girish Chandra, Parulji, and Upendraji, who have taken all the pains, to take up this, and all the people who are, to whom I am not directly aware of, but they are working very, very hard to make this event a success event. We have been talking about AI and ML, and previous speakers stressed upon the importance and the advent and the uses of AI. I think I have to just add, the applications of AI is everywhere. And this is one of the subject which we have been studying, early days of our BTech computer science in early 80s. Now, having in early 80s, artificial intelligence till, the third decade of this 21st century. We have been talking about AI with fashion and glamour. So it is the advancement of algorithm which has made it so popular and so close to the heart, having an application everywhere, not only the defense, agriculture, everywhere. And now you have the applications of AI to the computer science itself. We have been, the organizations, the industries, IBMs, and many more are working on automating and using AI into SDLC. We have been talking about clouds and clouds to the hybrid clouds and meta clouds and using AI and ML into it also. So what to talk? I think talking about AI applications, and AI is not the only thing. When we are talking about the emergence technology, maybe the IoT, the cloud, the quantum computing, bioinformatics, many more technology which are coming up and taking the front field. And it's a working era of when we are talking about in a collaborative work. So what I look forward and what I stress upon always, talking about AI is good. AI would be taking a front seat, but what about the natural intelligence? It can never take a backstage, and it cannot be on a backseat. We have to always keep our natural intelligence active and always look forward to create much more and many more advancement in AI and these kind of technologies. As always has been said, that there has been a time of Corona and the things were online. But were they on the line? That is a question mark. That we need to decide with our natural intelligence. I'm sure, as it has been told, there has been, 18% paper acceptance ratio. And there have been a huge, popularity, and the people are aspiring to submit the papers. We look forward, next version, not only the virtual mode to be in physical mode. And we look forward, we to host at IIT Lucknow. And we look forward to welcome all of you at IIT Lucknow. And next year, from today, we can plan it accordingly. We also look forward, we can have, the best paper awards and best doctoral thesis award also. If we can try, and I look forward, the organizing team at IIT Lucknow and Dr. Deepak and others also to take into this and to promote our young researchers to come forward and to be the part of this wonderful initiative. With these words, I would like to, extend my all best wishes and all the speakers to whom I could see on the screen, Professor Payal, Samir ji, Aditya ji, and Professor Robert, and other people. I look forward. Their participation will make this doctoral symposium a value-added event, and all the researchers who would be the part of this event today and tomorrow would be benefited one way or the other. And all best wishes, all good luck. Thank you very much.
Thank you, sir, for your empowering speech. Now I request Dr. Samir Anand, Department of Operational Research, University of Delhi, Joint Convener DoSCI 2024 and ComSIA 2024 for conveying a vote of thanks.
Thank you, Kabya. Thank you, Nabia. Ladies and gentlemen, on the behalf of organizing committee, I extend my heartfelt gratitude to all esteemed dignitaries, scholars, participants for the gracious us the presence of the International Conference on Computing Communication System for Industrial Applications, ComSIA 2024 and DoSCI 2024. It has been an enriching experience for all of us. We express our sincere appreciation to Professor J.P. Pandey, Vice Chancellor, AKTU, Lucknow, for his invaluable support as a chief patron for this event. I would like to thank to Professor Payal Mango, Director, Campus of Applied Learning, University of Delhi, for unwavering patronage as a patron, ma'am. Ma'am, your trust on us made us more accountable to meet your expectation, ma'am. Thank you so much. I would like to deeply thank to Professor Vineet Kansal, Director, IIT Lucknow. Our heartfelt gratitude goes to our Professor Girish Chandra, Professor D.S. Yadav, along with Professor Y.N. Singh for their remarkable contribution as General Chair. We are also immensely grateful to Professor Ajay Jaiswal, Principal, School of Open Learning, Giancarlo Fortino. Thank you, sir. I would also like to thank to distinguished keynote speaker, Professor Robert, Professor Lalit Garg, for sharing their expertise and enlightening us with their profound knowledge. A special note of thanks to our technical program chair, Professor Manish Gaur, Professor H. Khan, Professor Manik Chandra for their meticulous planning and execution for the technical session. We are indebted to all members of the organizing committee and organizing team for their tireless effort in making this event a grand success. Last but not the least, I extend my sincere gratitude to all the participants for their active involvement and enthusiastic participation, which has made this symposium a memorable one. A special thanks to Deepak Gupta ji, who is instrumental for entire event to happen. Thank you, Deepak ji. Thank you once again for your unwavering support and collaboration. We look forward for your continued patronage in our future endeavor. Thank you so much.
Thank you, sir, for your kind words. Now, Professor Dr. Robertus Damasiovis received the PhD degree in Informatics Engineering from the Kaunas University of Technology, KTU, Lithuania in 2005. He is currently a professor with the Department of Software Engineering and director of Real-Time Computer Systems Center at KTU, a professor with the Department of Applied Informatics, Vytautas Magnus University, Lithuania, and an adjunct professor with the Faculty of Applied Mathematics, Silesian University of Technology, Poland. He lectures software maintenance, human-computer interface design, and robot programming courses. He is the author of more than 600 articles and a monograph published by Springer. His research interests include smart learning, assisted living, and digital health. He is also the editor-in-chief of the Informatics Technology and Control Journal and an associate editor at the International Journal of the Imaging Systems and Technology. He has been the guest editor of several invited issues of the international journals such as Biomed Research International, Computational Intelligence, and Neuroscience, Journal of Healthcare Engineering, IEEE Access, Sensors, and Electronics. Over to you, sir.
Thank you very much for the distinguished professors and chairs and research presidents for inviting me to make a keynote presentation for this conference. I hope that this presentation will be very useful for the participants of the conference, also for the doctoral students. Today I will speak about various cases or applications of Internet of Things. And I think that is a topic which is important both for ComSI conference, which is dedicated to computing and communication systems in industrial automation and control, a field the Internet of Things has become a cornerstone technology. Also, it is highly relevant for the doctoral symposium, which places a great focus on computational intelligence, directly benefiting from the advancements in Internet of Things, as these devices generate vast amounts of data which are vital for training algorithms in machine learning and computational intelligence. So first of all, I would like to start from a short historical excursion into the past. Actually, this year we celebrate 25th anniversary of the term Internet of Things itself, because it was introduced or proposed back in 1999 by Professor Kevin Ashton, who linked radio frequency identification devices in supply chains to Internet, in this way introducing the concept of Internet of Things, which led to revolutionizing many areas of research and also of our daily life. So starting from some basic things, from foundational elements of Internet of Things, which represent the integration of functionality of Internet of Things systems across various applications. So first of all, of course, it's sensors, which are the devices responsible for data collection and also using this data further downstream by other devices and applications. Sensors can monitor a very wide range of environmental inputs, ranging from simple temperature measurements to complex full spectrum chemical analysis of the materials. And of course, these sensors of things, they would not be accessible without connectivity, because the effectiveness of Internet of Things system is largely dependent on the ability of devices, of things connected to the network, to communicate reliably and efficiently. And connectivity technologies such as Wi-Fi, Bluetooth, and recently 5G networks are key, because they enable devices within IoT ecosystem to transmit and receive data across substantial distances with minimal latency. And this is very important for recent applications of Internet of Things, which are going wider. So they are going beyond smart houses and even smart cities to cover much wider areas of land, of territory. For example, smart forests, so covering very large areas which are beyond the applications usually explored. Also, cloud computing is very important, because data generated by IoT devices require robust processing and storage solutions, and cloud computing offers a scalable and efficient platform where data can be stored, analyzed, and managed effectively. The cloud serves as a centralized repository where data analytics and machine learning algorithms can be applied to extract meaningful insights from the data, and which are then used to optimize performance and predict behaviors of various systems. In order to optimize the collection and sending of data, because it's big data, so it can easily just clog the data transmission infrastructure, usually edge computing is involved, which allows for processing data near the actual source of data generation. So if you can extract some useful or most important features from the data in this way, compressing the amount of useful data, so edge computing should be applied in order to reduce data transmission latency, conserve transmission bandwidth, and enhance response times. And of course, this data can be used for data analytics and machine learning, which includes tools and platforms which can analyze vast amounts of data generated by IoT devices to find patterns, predict outcomes, and automate decision-making processes in various domains of application, which I will discuss shortly in the next slides. And you can see the diagram on the slide, which actually demonstrates the nature of IoT ecosystem and its interconnectedness. Notice how each component, either the device or so-called thing, the network or cloud computing resource, they interact in order to enable the efficient use of resources and the analysis of data in order to achieve some useful application and benefit for the users and the society. So this main principles or core principles of IoT, interconnectivity, sensing, intelligence, dynamic changes, they contribute to the success of IoT technology. Specifically, sensing focuses on data collection. Interconnectivity forms a robust network of interconnected devices, and I must mention that we have diverse devices. So the network should be able to accommodate various types of devices, which should be able to enable seamless operation of Internet of Things so that these devices could function collaboratively rather than in isolation. Also, for Internet of Things, artificial intelligence is essential for making intelligent decision making. So data collected by IoT devices is not merely some raw information, but it is processed and analyzed using advanced algorithms and computing techniques, often in real time, because that is a requirement from many fields of application. And this intelligence is applied to make autonomous decisions, which can optimize processes, reduce human intervention, and enhance efficiency. And another thing which is very important for Internet of Things is the ability of IoT systems to face dynamic changes both in its environment and also in its composition, so that the infrastructure is able to expand in order to adapt new devices and integrate fresh information seamlessly into the existing network. The importance of IoT comes from the recent trend of digitalization of various industries and areas of activity. So I can mention the ongoing fourth industrial revolution, which aims at digitalization and automation of the industrial manufacturing processes, so that so-called smart factories are established, which rely on a very minimal level on the input of human labor. They mostly automate all the processes, include robotics, and in this sense, the Internet of Things represent a crucial part of this trend. So the role of IoT begins with the implementation of within the existing processes and IT infrastructures, so that IoT can enhance operational efficiencies and create new capabilities. If you consider, for example, a domain of mobile commerce and various social media platforms, they have integrated IoT to streamline consumer interactions and data transactions in order to enhance user experiences and provide operational agility. In the adaptation phase, the business models need to be modified in order to make use of IoT capabilities. This includes the adoption of various services provided by IoT, such as location-based services, cloud computing, in order to allow businesses to offer more personalized services and maintain flexibility in operations. As companies adapt, they redefine their workflows and expand their technological footprints. IoT extends the reach of digital capabilities into new applications and new fields. So this extension stage can introduce new innovations, such as, for example, voice over IP, and also the connected devices, so that businesses can explore new markets and service models and expand beyond the traditional reach so that they can integrate their customers and devices into one interactive network. By employing the specialization, the businesses can gain the ability to specialize the offerings to meet specific market needs more accurately. So the data which is which is collected by IoT can be used to refine products and services in order to enhance decision making and enable strategic planning in the businesses. The final transformation, which is brought by IoT, is the segmentation of business operations, so that they align more closely with specific customer demographics and needs, and this segmentation is supported by IoT through enhanced data analytics. So the concept of the concept of adopting the Internet of Things over various domains had led to offsprings of IoT technology, which is specifically adapted and focusing on very specific areas of life and applications such as smart cities or medical field or agriculture or energy field. These offsprings, they make benefit and use of the technologies of IoT in order to provide specific services targeted for the domain of application. For example, the so-called urban Internet of Things is adopted to the needs and requirements of smart cities, specifically focusing on urban areas. So it involves connecting various urban elements like street lights, traffic signals, pollution sensors in order to optimize the management of urban environments in order to improve living conditions of people in the cities. Also, I can mention such examples of IoT adoption like Internet of battlefield things, which is a military-focused application of IoT, including connected technologies for surveillance, reconnaissance, and combat operations for war applications. And sensors and devices can be used to gather intelligence, monitor conditions, and maintain communication in various military contexts. Also, Internet of Vehicles can be mentioned, which is a specific adoption of IoT within the transportation domain. So it includes connected cars and traffic management systems and infrastructure monitoring in order to enable vehicles to communicate with each other, and with road infrastructure in order to improve traffic flows, reduce accidents, and lower emissions, both inside cities but also outside of the cities while traveling between the cities. Also, I can mention the smart grids, also called energy IoT, which uses smart grid technologies primarily for energy management in order to enable utility providers to more effectively distribute electricity based on real-time data and consumption patterns. So each of these offsprings of IoT is geared toward optimizing specific areas of application, specific activities within these segments of our lives and industries, and it is proving the broad applicability and transformative potential of IoT technology. So now I will consider several use cases of IoT adoption in various domains in order to provide broad understanding of this ongoing transformative process. So in the area of industrial manufacturing, the so-called Internet of Industrial Things is adopted, and it is characterized by its ability to harness real-time data and apply advanced analytics in order to enable smart manufacturing and industrial processes. The components of this Internet of Industrial Things, of course, include smart sensors in order to collect required data for making or enabling the industrial manufacturing, but also, most notably, it also includes the industrial robots, which are the automated systems that can perform tasks with precision and efficiency. And the use of the robots allows to reduce human error in the process and to accelerate production capabilities, also improve the efficiency of processes, especially for various repetitive tasks, because robots can make this task much more faster and with a smaller margin of error. And of course, in order to synchronize the operations of robots in assembling some parts, for example, in the industrial context, requires collection of data and management of data in real time, because this synchronization must be done in real time in order to avoid various accidents and damage to the industrial equipment. The key applications of Internet of Industrial Things are primarily focusing on predictive maintenance, so that it includes using sensor data to foresee and prevent potential equipment failures in smart factories. Because if something fails, you need to stop all the manufacturing line, you need to examine the cause of this accident and replace the equipment, and it will take a lot of time and is financial costly, because this downtime means that the production process needs to be stopped. So that's why predictive maintenance is important, in order to predict the accident in the future, so that you can take preventive measures in order to avoid it. For example, to replace the soon-to-be faulty equipment by up-to-date working equipment, which can be planned in advance, and this can be done much faster than in case of accident. And for asset tracking and management, it is important to monitor the produced inventory in real time, so that you can send it to the logistic storage and to the clients, in order to streamline the supply chain processes. Also, Internet of Things has been very successfully adopted to the field of healthcare, so-called Internet of Medical Things or Internet of Healthcare Things, represents an advancement in integrating medical devices and applications through online networks in order to enhance the delivery of healthcare services. So this technology involves a variety of components, mostly focusing on medical devices, and in this case, it could be various wearable devices such as fitness bands, smartwatches, and also some specialized devices like devices for monitoring heart rate and blood glucose levels, so that these devices can provide continuous health data that can be critical for managing chronic disease conditions, and also connecting a lot of data which is needed in order to understand the process of disease, and also for preventive healthcare, so that the diseases can be recognized at early stage. And if recognized at early stage, of course, any medication and the use of drugs can be much more effective, and the person can be made healthy at a better rate. And of course, it also bridges this gap of lack of medical data, because usually not so many people arrive at hospitals and can be subject to comprehensive evaluation of the state of health, because the capacity of medical facilities is limited. But in case of wearables, you can make it very popular, and much more people can share the health data, which is very beneficial for researchers, especially in the field of artificial intelligence, because the more data you have, the better models you can train. Well, also, this Internet of Medical Things includes the healthcare infrastructure, so that this collected data can be sent directly to servers, to health hospital management systems, to patient care systems, and telemedicine platforms. So in case of any worsening of the health, or alert of impeding stroke, for example, the device can send the alert directly to the hospital and call for help, for example, so that this help can be provided for the person much more quickly. So key applications is, first of all, the remote monitoring of the state of health. Also, it provides tools for managing chronic conditions and various long-term diseases, which requires long-term observation of the health state of the person. And it is also important for the elderly care, so that the conditions can be monitored remotely using the data collected from the sensors, either wearable or just installed in the rooms of these persons. And Internet of Medical Things also related to the so-called Internet of Assisted Living Things. So this is an innovative application of Internet of Things technology, which is specifically designed to enhance the quality of life and independence of elderly and disabled individuals. And by integrating various connected devices into everyday living environments, it offers services which ensure that elderly individuals or disabled individuals can live safely in their houses, and they can age in place, and their disabilities can be managed in order to provide greater autonomy. The key components of Internet of Assisted Living Things are smart home devices, various wearable health monitors, and emergency response systems. The smart home devices mostly provide automated control services, such as control lighting, temperature in the room, also security, so that people who have difficulties with moving, maybe they have some disabilities, they could control the environment without the need of assistance, using some voice commands, for example, or some remote controls. And wearable health monitors, they are another component which used to track vital signs like heart rate and detecting falls, which is a significant source of various traumas at house. And if a fall is detected and help is called quickly, the prognosis for saving this person from dying maybe is much better if the help, medical help arrives in time. So the key applications are, first of all, the remote health monitoring in order to observe these health parameters and prevent various emergencies. Also, daily living assistance, so that to assist the persons with daily tasks, improve their independence and comfort in their living environment, and also allowing for social interaction so that the person could be able to communicate with relatives or with the medical doctor remotely, which is especially relevant for people living in remote areas. Another application of Internet of Things is so-called Internet of Agricultural Things, which represents the adoption of IoT technologies to modern agriculture in order to enable the use of smart farming, or also called precision farming practices, to enhance the efficiency and productivity of agriculture, and also to enable sustainability of these practices. So at the core are sensors which are directly deployed to the fields to monitor crucial environment parameters such as soil moisture, temperature, and crop health. And these sensors, they return real-time data that is essential for managing agricultural operations efficiently, so that the farmers know if they need to give some water to their plants, or to spray with some fertilizers, or to fight with insects and bugs with pesticides. Also, it is integrated with data coming from satellites and from the drones to provide the overhead view of the fields in order that any problems with crops can be identified and resolved more quickly. And this data is integrated with automated machinery such as tractors, harvesters, equipped with GPS signals and IoT connectivity for enabling the precision farming practices. Here you can see another interesting case of adopting IoT specifically to the natural and wild environments. So these environments which are beyond the reach of traditional human activities. And this is the emerging trend of expanding the reach of technologies beyond the locations where people live, such as urban areas. And this specific technology is adopted in order to monitor wild animals in the natural living environment, in order to preserve these environments and preserve wildlife habitats, which is essential for the protection of these environmental resources, which in many cases are just pushed by human activities and in many cases reduced. So that includes various cameras placed in natural environment in order to capture images of wildlife. And these cameras have image recognition capabilities, which means that they can process and analyze the images to identify the animals they see, and the data from these cameras is sent to the servers using long-range radio modems, which can communicate wirelessly, because here we have wild environment which usually take large areas. And it is integrated with various other technologies such as display boards or smartphones, in order that people who are tasked with preserving this environment, such as park rangers or environment conservation people. They can observe this information and they can take actions, for example, in case of illegal poaching, which is highly relevant in many countries, such as in African countries. Here you can see another interesting approach, which is called Internet of Forest Things, which is specifically an adoption of IoT technology through the use of forest sensor network to incorporate the elements of robotics, drone technology in the forest environment. So this integrated approach allows for data collection and monitoring of forest environments in order to collect data about the state of health of forest. And this is important for forest managers because it enables them to take strategic decisions which can help to increase the productivity of forests, because forests are managed in order to grow the trees so that they can be cut and then replaced with new trees. So in order to maximize the efficiency of this logging and tree growth process, you must know and observe for many factors. For example, if some fire happens, it can destroy large areas of forest, making it not profitable for many years to come. So all these remote sensing devices like drones or satellites, they can be employed as a data source for early detection of forest wildfires, so that these wildfires can be effectively put down, saving the forest areas. Also, they can be used for protective and predictive analytics. So you can predict the areas which are most likely be susceptible for forest fires, and the forest managers can take preventive actions such as partial cutting of these areas or installing additional sensors for monitoring in order to prevent these areas from forest fires. And this is represented especially by this concept of human in the loop, because the data is of course analyzed by machine learning algorithms, by artificial intelligence, but the analysis of this data still must be interpreted by humans so that they could take the informed decisions in this area. Internet of Robotic Things represents the significant evolution of integrating robotics and Internet of Things technology, which involves connecting robots to the internet to enable communication and interaction with the environment and systems. And of course, it's partly related to Internet of Industrial Things, which I discussed before, because robots are extensively used in smart factories, but it also includes other applications of robotics, such as smart houses, where robots can be used to perform some useful household tasks, such as cleaning of some areas. And this integration of robots can be used both for collecting data, but also to share the effective solutions between robots in order to optimize their activities. Also, robots can be employed effectively also in retail environments and in shopping centers to provide information about various goods also in museums to provide information about the various exhibits, and also in hospitals to relieve the burden from nurses and other medical personnel, which is usually tasked with carrying various equipment and drugs in the hospital environment. Internet of Emergency Services. So this concept also shows how the Internet of Things technologies proliferating not only on the things level, but also on the services level to enhance the delivery of services. So this specific case represents the integration of Internet of Things into emergency management systems, so that the effectiveness and responsiveness of emergency systems can be improved. And it includes various devices, both local connected devices, wearable devices, but also remote devices. So local wearable devices can be used to monitor the position and health and location of the emergency response personnel. The remote devices, such as drones, can be used for aerial surveillance and for detecting various hazardous materials and environmental conditions in the areas in which some kind of disaster has happened, such as earthquake or flooding or volcano eruption or some man-related accidents, such as accidents at factories, at oil processing facilities, which can release some dangerous chemicals, and the responders must respond quickly in order to provide help for the victims, to find these victims, but also to be able to track these emergency incidents in real time. And all this data collected by these various kinds of sensors also can be used together with historical data to predict various emergency scenarios with ongoing emergencies, so that the best response scenario can be selected for each specific case. The benefits of Internet of Emergency Services, of course, increased efficiency, so that the teams can provide quicker response and coordinated efforts. Also, it allows for better situational awareness for responders, and also it allows for optimal allocation of resources based on real-time data. And this is an ongoing area of research, and in future it is expected that it will be integrating with augmented reality, so that vital emergency-related information is overlaid on real-world view of first responders. Also, it involves the use of advanced robotics in order to deploy robots and drones in cases where the environment is too dangerous for the responders to arrive and provide help for the victims. And this Internet of Services, in the most ideal case, should be also integrated with other smart city infrastructure, so that it can provide immediate alert services and immediate response in case of accidents in the city infrastructure environments. Internet of Behaviors is representing a very interesting intersection of technology, data analytics, and behavior science in order to focus on how data is collected from various IT devices, so that it can be analyzed and utilized to influence human behavior. So it does go beyond simple data collection, because it integrates deep analysis in order to actively shape human actions based on the insights gained from user interactions with technology. and it uses a wide range of data sources, including smart home devices, wearables, online activity trackers, also mobile apps, and user activity on the internet, in order to collect big amounts of data on user activities, preferences, and interactions. And this data, once collected, it can be processed using sophisticated analytics tools and machine learning models that can interpret user behavior, predict future actions, and identify patterns. And this analytical capability allows for personalized interventions where automated systems can deliver targeted messages, notifications, and even adjust user interfaces of various software systems and devices to encourage and support specific behaviors which is beneficial to the society and to greater benefit. For example, in healthcare, it can be used to support healthy lifestyle so that the users are encouraged, for example, to take a walk, to use bikes instead of cars in order to prevent environmental pollution and prevent adverse health effects due to inactivities. It also can be used in a variety of other applications. For example, in workplace management, Internet of Behaviors analyzes data related to employee productivity and well-being, and it helps to improve efficiency of work processes, improve labor conditions, and also provide greater profits for the employer. So it represents a tool, a powerful tool, which can be used to understand and influence human behavior, merging capabilities of Internet of Things with the insights of the behavioral science. And this integration holds the potential to transform various activities of our everyday life, from personal health management to consumer behavior and workplace efficiency, making it a critical part of our future life. This specific case of Internet of Things is called Internet of Everything. It aims to combine all these cases or domain-specific applications of Internet of Things into a common infrastructure which represents the integration of devices, people, processes, and data aimed at enhancing the efficiency and functionality of various systems and services across different sectors. So by linking all these components, things, data, people, and processes, it will allow a more personalized interactions and enhanced execution of processes. The key applications of this combined infrastructure, first of all, would be smart cities, so that it would be able to enhance urban infrastructure, transportation, and services via integration of these technologies, but also healthcare to integrate patient data, medical devices, and healthcare providers to improve the patient outcomes. So in this slide, I'm summarizing all these discussed offsprings of IoT or use cases of IoT, which provides a panoramic view of how IoT technologies are specifically tailored and implemented across different domains in order to solve unique challenges. And this comparison not only underscores the versatility of IoT technologies, but also highlights the convergence of technology, data analytics, and sector-specific needs in order to enhance operational efficiencies and address complex issues. What insights can be made from this table? First of all, each offspring of IoT employs technologies and devices that are specifically tuned to the environmental and operational demands. Also, a common theme is the drive towards integration and automation within the device, within each domain, so that the specific activities or specific operations performed in these domains are automated to improve efficiency and to reduce the amount of human labor and the probability of human error while doing some domain-specific activities. Also, these cases, they provide enhanced decision making by aggregating and analyzing data from multiple sources and sectors like manufacturing, healthcare, and emergency sensors. The people can make informed decisions faster at every level, which can impact the productivity of these sensors, of these sectors. Also, IoT sensors, they're essential in promoting sustainability and environmental monitoring, which is specifically evident from such sectors as agriculture and forestry. Finally, in order to implement this kind of infrastructure successfully, the problems of data privacy, data security, and interoperability must be addressed, because in many cases, the data that is collected and shared by IoT devices is private and it is sensitive, especially it is related to the medical and health data. So appropriate levels of security must be ensured in order to prevent this data from leaking to public domain, so that it is used only by the dedicated medical doctors, for example, in the domain of healthcare. So, going in the end of my presentation, I would like also to discuss some future outlook and areas of exploration regarding the application of IoT technologies. And it's actually a very perspective area of research, and many various new applications can be considered, and this especially I think would be relevant for the students, also for the doctoral students, because you can consider new applications of IoT technologies in your works and your studies, and researching these new and explored areas can be very interesting and attractive things. So these are the still unexplored areas of application of IoT. If you look at Google search, you would not find many links discussing this kind of domains and this kind of use cases. For example, you can analyze Internet of biotech things, which would merge IoT with synthetic biology in order to control biological systems, which is a step beyond robotic systems, because currently robots are like mechanical. They are done from the mechanical parts assembled from metal or plastic, but the future would be with synthetic biology, and how to integrate it with Internet of Things infrastructure is an open research question. Similarly, the Internet of Quantum Things represents another innovative frontier, incorporating quantum computing to bolster the capabilities of IoT, because it provides quantum computing promises to enhance both processing power and also security, opening new applications in secure communications, advanced cryptography, and complex system simulations. Similarly, with space exploration, and I know that many countries are now investing heavily in space exploration, and especially I want to congratulate the achievements of India's space program in the lunar exploration. So Internet of space things would be a very relevant area of research with regards as more and more devices are launched into space, and they need to communicate to each other and share the data and send it to the Earth. The Internet of Nano Things would explore the integration of nanotechnology within IT frameworks, deploying nanoscale devices that operate at cellular and molecular levels. And this is especially relevant for advanced future medical applications, which would need targeted drug delivery systems and real-time disease monitoring from inside of the body. And here you can see another promising areas of research which has not been attracting the attention of researchers yet, such as Internet of Sports things, which would enhance athletic performance of sport participants using combining wearables with collection of personalized data to provide insights into physiology and biomechanics of sportsmen. Also, Internet of Logistics things in order to manage the supply chains and logistics of various goods delivered over long distances, so that the supply chains end-to-end can be optimized. Internet of Psychological things would involve using IoT devices to monitor mental health and emotional well-being of the users and provide recommendations how to improve the mental conditions, what exercises to take, and how to improve overall well-being. And also Internet of Cultural Heritage things aimed at preserving our precious cultural heritage, which is especially relevant in India, with a lot of historical and cultural artifacts from historical periods are very important to be preserved and data collected, and this data when used to digitalize the cultural heritage sites and to provide the digital replicas or digital twins in the virtual environment, so that people around the world can see them and explore them in virtual reality environments. So in conclusion, as Internet of Things technologies, they continue to evolve, they are being integrated into various fields of human activities and various industries, which is a continuous process, and it requires enhancing capabilities, improving efficiencies, which is an ongoing area of research and requires the attention from the researchers and also future researchers and students. So I would encourage all students and researchers to address this ongoing research problems and gaps in order to continue this very relevant and attracting area of research. So thank you for being patient, and if you have any questions, I'm open to answer.
Thank you, sir, for your very informative presentation. Now, I would like to invite Aditya Kamparia, sir, to give a vote of thanks to Professor Robertas and Dr. Lalit Garg.
Thank you, Navya. On behalf of DoSCI 2024 and ComSIA, we express our sincere thanks to Professor Robertas for your exceptional presentation on latest cutting-edge technologies at the event. Your insights and expertise made a significant impact and we are grateful for your valuable contributions and thoughts on actuators and sensors, different usage of 5G devices, core principles of IoT, and its various dimensions. You have discussed on edge computing, cloud computing, data analytics, and machine learning. As you have explained how IoT become game changer in digitalization and transform business and human life rapidly with various use cases and aspects related to industrial IoT, industrial of medical things, industrial of vehicles, agri IoT, industrial Internet of Wild Things, robotic things, Internet of Emergency Services, and smart grids. Thank you very much, sir. Thank you again for sharing your knowledge and suggest future outlooks and making this event a success with your graceful presence. Thank you.
Thank you.
Over to Navya.
Yes, sir. Dr. Lalit Garg is an information technology innovator, academician, learner, teacher, developer, keynote speaker, consultant, and researcher with a demonstrated history of working in the higher education industry and an excellent research publication record. He is a skilled solving complex problems using machine learning and data analytics, especially in the medicine and healthcare domain. He is an associate professor in computer information systems at the University of Malta, and an honorary lecturer at the University of Liverpool, UK. He also has worked as a researcher at the Nanyang Technical University, Singapore, and the University of Ulster, UK. He has supervised more than 180 master's dissertations, guided 5 PhD theses, and shaped the future of many other students. He has published over 150 technical papers in referred high impact journals, conferences, and books, and some of his articles have been awarded Best Paper Awards. He has delivered more than 20 keynote speeches in different countries, organized, chaired, co chaired many international conferences, and contributed as a technical committee member or a reviewer of several high impact journals and reputed conferences. He participates in many EU and locally funded projects, including a €1 million Erasmus Plus capacity building project in higher education titled Training for Medical Education via Innovative E-Technology and Malta Council of Science and Technology's Space Research Funds. The University of Malta has awarded him the 2021-2022 Research Excellence Award for exploring novel intelligent computing methods for healthcare requirement forecasting, allocation and management. He was awarded a research studentship in healthcare modeling to carry out his PhD research. Nominated for the Operational Research Society Doctoral Prize Most Distinguished Body of Research, leading to the award of a doctoral in the field of OR. He completed his postgraduate in Information Technology from ABV IIITM, Gwalior, India, and his first degree in Electronics and Communication Engineering from Barkatullah University, Bhopal, India. He has consulted numerous public and private organizations for their information systems and implementations. Over to you, sir.
Thank you very much indeed, Navya. A very good afternoon, good morning, or good evening, wherever you are. And I hope you have taken your lunch, breakfast, or dinner, and you are not just kept because of this presentation. And I hope you will enjoy, because I can see the number of participants quite high, 181. So great. So I hope you can see my slides.
Yes, sir.
Okay. So, well, this is Malta, where I'm presently situated, and this is the topic of my talk: satellite data analytics and digital twins based extended health intelligence. This is based on a project we recently completed But before discussing that, I would like to discuss some very basics. Well, we can start with the quote from Srimad Bhagavad Gita, chapter 2, verse 47, which is saying, Karmandevad karaste ma phaleshu kadachanma karma phale tu chango asti karmani. Or you have every right to work, but not expecting the fruits out of it. Let the focus be not on the fruits and never be inactive. Well, if you see it different way, it is saying there is a different, you can do deeds, but you can't control its outcome. So since then, there has been a quest to control the outcome. But interestingly, even in the same book, they have given the solution controlling the outcome. So, which is saying the Gyan Yoga for the followers of the path of knowledge and Karma Yoga for the followers of the path of action. So, by knowledge, you can ensure the outcome is as expected, not by 100%, but in a good degree of predictability there. So that in the next chapter, chapter 3, verse 3. So since then, the quest took us to intelligence and then controlling the intelligence or knowledge previously collected. And that way, if you control that and you can analyze, it is slowly moving towards the artificial intelligence. So I can say that is the beginning of the work towards artificial intelligence. And for understanding that, we have to first understand a system, which means there are more than one entities interacting with each other, and the change in their state depends on that interaction. So if we can understand that interaction, then we can predict the next state. So interaction is our deeds and next stage is its response. So you can see here, if there are large number of such entities, it becomes too complex to understand all these interactions. Thankfully, with the help of latest development, we are moving or advancing in even understanding these complex systems and then to predict its next stage. Okay. The only barrier is, even in that shloka, that is saying is the difference between our perception and what is real. And many times we work with our perception, ignoring the reality. But thankfully, machines work with reality. So we can see one example of that, that is the very first algorithm in artificial intelligence called hill climbing. So if you want to climb a hill, that is your ultimate goal, and you are at the very beginning of that terrain. Okay? So you can't see, you can see only local maxima, but you can't see global maxima. But if you plan based on whatever you can see, when you reach local maxima, you will realize your decision was not as you expected, and you have to travel too much. Okay? So you might develop nervousness or many issues. Okay? But if you know already there is also a global maxima, then you can ensure whatever problems come, you can reach to global maxima. Another possibility is, if you do not know because you have never been there and there is no one who can tell you that, if there is a knowledge which you can analyze and you can find out there is global maxima. But if there is no one, they have been there and you are the first person, then you can still assume that whatever you are seeing might be only your perception and reality might be slightly different. That will save you from many issues you might face by ignoring this fact. Okay? So we realized that our decision making depends on or based on this terrain. Okay? So depending on how much uncertainty is there. So if you start from the very beginning of the terrain and you can see only local maxima and you perceive that is the global maxima, you will start, and then when you realize no, there is something else, you will change your way of making decisions, and you will start taking only short-term decisions. While if you have more stability, okay, and because of the availability of knowledge, then you might start taking long-term decisions. So if you take short-term decisions, which might compromise your long-term well-being, and for a national level or even at individual level, that will make the country or nation developing slowly. While if you have that knowledge, you will take long-term decisions, and that will make you and your nation developing faster. Okay, so you can see this algorithm is also explaining why a country is developed and developing. So we need stability or more knowledge to deal with uncertainty. If you are not agree, don't worry. There is another algorithm which is further explaining the same thing, which is called greedy algorithm. So this is a classical traveling salesman problem. You are at one of the cities and you have to travel the remaining 5 cities, and you want to find out the shortest path. Okay? But if there is huge uncertainty, what you will do is, okay, let us go to the nearest city. Then we will decide which city we should travel next. Okay, this is called best first search, obviously. Okay, and that way you can see if you travel like that, because there is huge uncertainty, you don't know if you will find another place to go to the next city, or there is a road to open, or it is closed, or what time you will reach, how long it might take. Then you will travel this much. While if you use Google map or some other GPS systems like in India now, you will make an optimum path before starting your travel, and you will realize you require to travel far less than if you don't plan accordingly. As well as if you need to finish this job and your friend is also allocated the same job, you can see you can finish that job quite earlier than your friend. So you will be always ahead of your friend who is using the traditional way, not the knowledge available, or creating the knowledge system. So you can see how you can avoid this uncertainty by knowing many things in advance, and that will keep you ahead. And at a national level, that plays a big role. So you can see here you start with perception, while in other case, you see all the reality beforehand and make your decision. So the same thing we can apply in healthcare. So here is the why that happens, because the human intelligence is quite limited, because knowledge collection is limited to 5 senses and stored knowledge somewhere, maybe in books. Okay? Then knowledge processing is limited, and it might be biased based on our experience. Okay? And we can verify that knowledge by acting on the outcome of knowledge processing. Okay? But we have very few chances to verify that, because we can take only limited access. So we are getting limited feedback. So it might remain quite biased. Okay? While if you use extended intelligence or extended or machine learning, okay, then you can collect unlimited knowledge by using various sensors, and you can ensure the correctness of that knowledge. And then you can also ensure processing of that knowledge is unbiased, and you can simulate a large number of times, or virtually infinite times, to see whatever knowledge you have is correct or incorrect. If this is incorrect, you can use reinforcement learning to correct. So at the end, you will get the correct knowledge. So by using this phenomena, we are working on technique called digital twin. okay, and its applications in healthcare. Well, this is not a new technique. Okay, it is being utilized quite a lot in manufacturing, but yes, we can also use this technique in healthcare. We can also call it digital U because it is a digital representation of you. Okay. So it can help to ensure bed availability, to estimate waiting time, to have healthcare professionals available, or it can help you to understand or analyze the impact of various environmental factors on your health or public health. Okay. It can also help you to minimize the disease risk, can assist or correct diagnosis, take care of your health. Okay. Even for hospitals, it can help better capacity planning, discharge planning, and optimize the utilization of the scarce resources and optimum management. Okay. So it can also find out these or characterize the impact of weather on not only on disease but also on its spread, okay, so that we can prepare our healthcare system to deal with that spread, okay, and make public policies and alert public. Okay. So what is that? It looks like magical, isn't it? No, it's not magical. It is well systematic development. It started with predictive and prescriptive analysis. Okay. So what is predictive health analysis? Well, you collect information about a patient or you, okay, and then or a general public, okay, and then analyze that to predict health status, disease risk, and impact of various factors which can affect your health status and disease risk. Okay. So these factors might be your genetic makeup or genomic profile, environmental factors like weather, pollution, geography, diet, medicine, sleep, stress, lifestyle, and activities including contact tracing, okay, exercise and therapy, relationships, okay, and also social and economic status might affect. Okay. Now, you can predict, okay, what the disease risk is there or how is your health. So what? Well, based on that, you can prescribe what is the best. Keep your health or to prevent any disease. Okay? So it can minimize disease risk and improve or ensure health and well. That's called prescriptive health analysis. So prescription might include, okay, not only just treatment but controlling environmental factors. So for example, if weather is creating problem, you can go to a more favorable weather, or you can have air conditioner, temperature control, all these. It might prescribe you diets or medicines, sleep, stress, lifestyle changes, exercise therapy, if needed, some medical tests or investigations. And if you can't avoid, then treatment, surgery, or gene editing. Okay. Not only that, but it can also give you precautions so that you are prepared for any disease risk and or health events, okay, and continuously monitor so that you can update these prescriptions. So digital twin is combining both of these prescriptive health analytics and predictive health analytics, and as well as it is analyzing each of these prescriptions and selecting the best prescription. So it is a digital copy of a person like you, containing all required information, or we might say all available information about you, together with your 3D image scan, genetic makeup or genomic profile, whatever we have seen in predictive analytics. Okay, so your general information, height, weight, shape, BMI, your genomic profile and phenotype, your medical history, family history, your diet, activity, travel history, your predictive or prescriptive analysis. So you can keep it at one place, okay, but at the same time you can share it with your doctors or others by selecting the information you want to share. So it is representing your physiology, okay, in a computer model, obviously, and it may enhance medical care because it will be able to select the best treatment or intervention necessary by simulating all possible interventions and getting their outcome before actually applying it to you, and then selecting the one which is providing the best outcome. So you might have a optimized patient specific treatment. Okay, so you have seen all the information. Then it will build a layout and all the equipment, and then whatever personal resources needed. If you know everyone is, or you have everyone's digital twin of a population, you can also predict how many resources are required, how many personnel are required to take care of these. Okay? So usage statistics, you can also analyze the healthcare system if everything is going well, or if there is anything which is unexpected based on the simulation, the results and the actual results are too different, then you can find out if there is something wrong going on. Okay, so it can not only help to take care of you but also complete health system. Okay, so it can ensure patient specific treatment. Okay, reducing or minimizing the cost. Okay, and patient will have control on his or her data as well as treatment, and it can also ensure fair and equal treatment of patients, less animal suffering. So because you are simulating the interventions, then you are not using animal or human for tests. Okay, so it uses sensitive data, so we have to use various techniques to keep that data secure. Okay, so we are proposing using a blockchain based and mm, other secure mechanism to keep and transfer your data securely. Okay. Then you can not only share your data, but also you can monetize that data if you prefer. Okay. So it can also help predicting health status, predicting disease risk, recognizing unexpected health changes, identifying factors affecting health, determining the most effective treatment, therapy, behavioral intervention, dietary intervention, okay, or improving monitoring of a patient who is having some chronic disease. Okay. It can also warn someone. So interestingly, if it is implemented well everywhere, then you need not to go to the doctor, but doctor will call you before you have a risk of any particular disease, so you can actually prevent the disease instead of curing that disease. It can also help understanding why a treatment is or intervention is carried out on you, okay, so that you can be well informed and you can give your choices treatments, okay, by seeing how that treatment or intervention will affect you. Okay, so that when you are making decisions yourself with the help of your physician, it will improve physician patient relationship. Okay, because you are well informed. Okay? Might also predict the resource requirements for the healthcare system. Okay? And also, because you get that disease risk in advance, you can ensure availability of resources. Okay? The focus will be on prevention, then cure, and reducing hospital visits. Okay? So, reducing hospital acquired infection, facilitating effective telemedicine. Okay? And we can also move towards medicine as an open loop system. So, means instead of just getting a medicine or treatment whenever you have an issue, you will be continuously monitored throughout your life, so lifelong. And instead of whenever there is a risk, it can help you to avoid that or minimize that risk. So better personalized medicine, reducing medical errors, controlling drug resistance, controlling hospital acquired infection, because there is little number of visits. Okay? You are getting drug only when it is essential, there is no other option. So it can reduce drug resistance. And yes, it can further reduce your insurance premium because healthcare cost will be less. Okay? Developing and sharing patient life log and promptly recognizing and containing infectious disease outbreak. It can also recognize responsible factors for non-communicable diseases like diabetes, heart disease. Okay? Better public health measures, okay? Even impact of these measures, okay, or policies we can simulate or predict, okay? And we can minimize the health fraud. Okay? So as a part of that, this is another project which is implementing that digital health twin. Okay? So this is part of a very large project which is called Digital Twin of Earth. Okay? So this is a small project which is part of a large project. It's having collaborative partners not only from academia but also from hospital, from meteorological organization and ministry. So this was the funding we got to Space Research Fund, okay, in collaboration with European Space Agency. So as I told you, this is part of a large project, Digital Twin of Earth. Okay. So that project is started in 2020, which implement Earth observation to the creation of digital twin of Earth. Okay. So a dynamic digital replica of our planet, which accurately mimic Earth's behavior. It can help you to understand various activities happening on Earth, how it can affect our future of our planet. So it can help to monitor environmental threats like rising sea levels, global warming, increasing ocean acidification, or more intense extreme events like floods, heat waves. Accurately model the Earth, okay? Study the environmental activities like forest erosion, okay? Hydrology, Antarctica impact, okay? Food systems, okay? Or impact on agriculture of environmental changes, ocean and climate spots. Okay? Can also observe near future effects of climate change on Mother Earth. Okay? So this is small video explaining the digital twin of Earth project as well as digital health twin project or space satellite for health project. Okay? So
Our Mother Earth, the only planet in the solar system.
are you able to hear the video?
Yes, sir.
Okay, good.
System accommodates many species, including us. Complex life on Mother Earth requires stable conditions to flourish. But due to the access-human interface on Earth geology and ecology, many global problems are introduced like global warming, rising sea level, forest erosion, and many more. As a result, life on Earth experiencing instability. Health Organization discovered that 3 million deaths a year are caused by air pollution and is recognized as a contributing factor in the onset of heart disease and cancer. Along with the air pollutants, we must consider other environmental factors like temperature, humidity. Air temperature affects air movement, and thus the movement of air pollution. Because energy from the sun is absorbed by the Earth's surface, air near the ground is warmer than air that is further up in the troposphere. The warmer, lighter air at the surface rises, and the cooler, heavier air in the upper troposphere sinks. This is known as convection, and it moves pollutants from the ground to higher altitudes. In the case of humidity, it is a combination of dry air and water vapor. The degree of combination of this duo ultimately determines how hot or cold the temperature is. This scenario comes alive when we feel intense body heat and skin irritation or shivering uncontrollably. High humidity increases the rate of harmful or toxic chemicals in the air. It also causes dust mites in our homes, dampening air quality. Bacterial and viral organisms that cause respiratory infections thrive due to high and low humidity. Low humidity also causes airborne germs. This entire scenario leads to critical situations which are not only harmful to humans but also to other species. We need to find a solution that stabilizes the conditions and leads us towards a better world that everyone deserves. The Digital Twin of Earth project is among the promising technologies that will provide the solution to save our Mother Earth. Suppose we succeed in implementing fusion of digital twin of Earth and digital twin technology in healthcare. In that case, it will highlight the effect of the Earth's changing environment on particular human replicas. We can digitally create an Earth-like climate to examine its internal and external impact on the human body with the existing health conditions. GIS can be used to explore collating open data to develop a digital twin of city air quality to inform public understanding of health issues, find ways to improve air quality, and move towards a healthy breathing city. We will be showcasing the impact of rapidly integrating multiple open data sources into an interactive digital twin using our cloud-based real-time simulation platform. In other words, healthcare scientists can tackle what-if scenarios without affecting the safety of individuals. The information that this project will generate, not to mention the insights that it will reveal, could drastically improve society's understanding of the challenges and risks of air pollution. More importantly, we will present multiple ways for reducing air pollution and allow cities to understand the importance of green energy, sustainable transport, e-waste management, e-mobility, and vegetation management. Moreover, every government needs to assess the air quality targets which are allocated to cities on an annual basis. Our little initiatives will make a huge difference for our future generations. We urge you, let's work together to make our Mother Earth livable and beautiful. After all, it's incredible in the universe. Our Mother Earth.
Okay, so digital twin of our project has 5 domains of application. One is aerospace, another is healthcare, another is wind farm, automobile, and manufacturing. So the satellite for health project, although we discussed in that video, but is describing more here.
Have you ever experienced a changing weather effect on your health? The answer is not that simple. Changing weather can have long-term adverse effects on the human body. We proposed a satellite for health project to identify primary climatic factors influencing public health, characterizing the impact of weather factors on hospital admissions and patient length of stay, modeling correlation between the satellite imagery and weather station data. Develop a public prototype of satellite-based health monitoring and resource requirement forecasting tools. ERA5 reanalysis data is used to collect meteorological data. At the same time, health data was collected from DHIR, and a novel holistic approach was developed to process the datasets and forecasting. We expect a novel tool that can predict the hospital admission rate and patient length of stay by considering weather factors. This project not only discloses the crucial effects of weather on health, but also helps us to improve our health facilities.
So, you got introduction of the project. So in more detail, it has various objectives to find the most significant satellite imagery data parameters influencing public health, okay, to investigate the effect of weather parameters on human health, to model the correlation between the satellite imagery and weather station data, to characterize the climate factors impact on the hospital admissions and patient length of stay, factors on the hospital admissions and patient length of stay, to develop public health monitoring and resource requirement forecasting tools. Okay, so in summary, okay, we are not monitoring the impact on individuals, but on the overall healthcare system. The beauty of this project is because it is being first implemented in Malta, which is a tiny island country. So we are able to access all the healthcare service across Malta, so we can know how many total patients or admissions happened in our hospitals. Okay? So that might give us a holistic picture. Okay? So because in other places, if this is a large, geographically large place and you do not have access to all data, then your analysis might have some bias. Okay, so we can avoid this bias here, being a tiny island. Okay, so we are using the various satellite data like from Sentinel, mainly Sentinel 5P and Sentinel 3, and Landsat, Terraqua, and UMETSA. And yes, Environmental and Resource Authority also provided us ground station data and free meteo, again, weather data from ground station and ERH, environmental data, okay, like pollution, all these. Okay. So we used these weather parameters. Okay. And Matardeh Hospital, which is the largest public hospital in this island, okay, provided us data, but it is not only having data for hospital, but it's satellite clinics as well. So we were able to monitor all the data, okay, including private hospital. Okay. So that was provided by the Directorate for Health Information Research, Ministry of Health, Malta. This is a schematic diagram of our proposed model. Okay. So we used Veblet transform, singular vector decomposition, okay, SVM, ELM, deep learning, random forest and time series analysis for analyzing satellite images, while we used prognostication and regression techniques like regression analysis, tensor decomposition, Bayesian probabilistic factorization, HMM regression, case type survival trees to establish the relationship between various environmental factors and health. So these are the programming languages used, Python, C++, okay. And yeah, these are the results. Okay, so we can see here, okay, so very brief results. So we are publishing the detailed some venues. Okay, so you can see here the variation in temperature from like the average temperature yesterday and average temperature today is having the maximum impact on health, while then maximum temperature is having impact on health. Okay. All other factors are having minimal impact like low temperature, okay, minimum temperature or average temperature. Okay. So similarly, so that's on number of health admissions, but we also find that how long a patient will stay in the hospital also impacted by the weather. Okay, so again, maximum temperature has the maximum impact than average temperature when maximum temperature is more than 20 centigrade. And if the average temperature is between 21 to 30 degrees centigrade, then minimum temperature also plays a role. Okay, so we also implemented our prototype of digital twin in mobile app. Okay. So that mobile app empowering patients to taking a proactive approach with regards to their health. Okay, so personalizing patient care, a more accurate patient health status patient can see. Okay, by remote monitoring, even the physician can see with properly, and it will strengthen the relationship between physician and patients. We have already seen that in digital case, so this is implementing that and reducing the strain on healthcare systems and its resources. So this was the purpose, to combine the existing technological services already offered along with machine learning techniques to make health services more accessible. So it has two, in fact, three panels. Okay, so first is patient can see, another is medical professional can see, and the third one is for the administrator, which can administer the chat. So patient features are patient dashboard, which can be customized, and medication tracker, appointments, symptoms, diagnostic. The patient can also talk to the GP through video conferencing chat. They can get appointments. It can also have a list of doctors available, patient education. There are videos. So patient can select videos based on his or her condition, then medical and surgical history of the patient, disease prevalence statistics, and environmental factor. Actually, this is accessing some of the data from My Health app, which is the government health in Malta, where you can see your data if you go to hospital. So if you get some investigation, then investigation results are there. If hospital is giving you some treatments, then these treatment results are there. While doctor can see medical record of the current patient he or she is monitoring, then medication prescriptions given, so that history, then tickets of referrals from where that patient is coming. Again, she can set video and chat appointments. Doctors can also see patient diagnostic reports, alert for irregular or life-threatening vitals. Some changes happen, then it can doctor can get alert, so that they can directly call the patient to take care of him, test or schedule the test, various test investigations, also having a patient life log if available. Okay. Then environmental factors which might help, predictive analytics results, prescriptive analytics results, treatment or intervention simulation, and explainable AI-based ranking and suggestions. Okay. So this is all about the digital health twins we have implemented, and these are some of the references. Okay. So I hope I didn't take too much of your time. Now I'm here to answer any of your questions if you have. And thank you very much indeed for your attention, time.
Thank you, sir. I'd like to invite Aditya Khamparia sir to give a vote of thanks to Dr. Lalit Garg.
Okay, thank you, Navya. On behalf of Organizing Committee of DoSCI and ComSIA, we express our sincere thanks to Professor Lalit Garg for your valuable insights on satellite for health and digital twins for health informatics at the event. Sir, you started with Indian philosophy and Bhagavad Gita slokas, which surely boosted our participants and described complex systems. Then you suggest how the reality and perception differs from each other through a usage of famous hill climbing and greedy algorithm. As you suggested, how digital twin can help and control disease outbreak and spread, alert public, and develop healthcare system. Predictive health analysis generates prescriptions, which includes medicines, diets, lifestyle changes, and investigations. Digital twin predict health status and improve patient monitoring and facilitates effective telemedicine. Thank you again, sir, for sharing your knowledge. Discuss your dream satellite project for health using digital twins. Your contributions and making this event a success with your graceful presence. Thank you very much, sir.
Thank you, Aditya, and all the very best to all participants. Okay, so enjoy the conference. Thank you.
Thank you. Thank you so much, sir. Lalit sir. Now, Aditya, you can create the rooms. We are creating the rooms for your session, and you will be assigned to your session respectively. So please, I request all the participants to please rename their profile name as session number underscore paper ID. So it will be easier for us to assign the respective session. All the session chairs are also requested to please, after their name, you can write the session number.